everyone. Welcome to this new episode of the Swift Academy, the podcast. Today, I'm glad to be with Tjeerd In, Veen, which is a senior iOS developer, have a lot of experience at Twitter and ENG, the author of the Swift In Depth, and also the mobile system design, who are two books reference in the iOS community. Hello, Tjeerd, and how are you?
Yeah, good morning. I'm good. How are you? Happy to be on the podcast.
Thank you. Also, it's a pleasure for me that you accept my invitation to be in this in the podcast. And
Yeah,
today
no
we'll
problem.
today we'll discuss a great topics, which is modularization in iOS application. You have
Hmm.
a lot of experience about these topics, and I try to discuss with you some ideas, especially how to work with
Hmm.
legacy code. When
Hmm.
we go to modularization, how we can define our model and our features, how we handle communication between models. You have a lot of experience about that, and we deep dive into in the podcast. First
Yeah.
of all, I have question about for you what constitute a features model in the context of modular architecture. It's limited to a single
Mhm.
screen, or does it include a complete workflow?
So, what is a feature is a very philosophical question. I quite
Okay.
like it. So, in my mind, I would consider. Um, so let's start with the smaller thing. Let's start with the view, right? View, screens, features. I think these get mixed up a lot. What I try to do is I consider a view as either like a primitive, like a label, button, and with these and if they have some more logic, they could be a component,
Okay.
right? So, for example, if I have like a map view, it's a component that does more, right? It loads data, it reacts to screen sizes more, etc. Has more logic, but it's not a feature on its own. I would say it's not like something you would just put in an app and ship. You would make something around it, and then on top of so you have the few primitives and then a few components, and on top of that, I would say you have feature views, which is a term I try to coin myself, I guess, is whereas there's business logic on top of everything else. And this is where a lot of developers call them screens,
Okay.
but I would disconnect those, first of all. So, for example, if I have, let's say, a large iPad or tablet, and I can put multiple of these feature views in there. So now the screen is not the original screen is not the screen, is now an iPad screen. So there's like a disconnect there between screen and feature views, I would say. So that will be like a single feature view would be like a single sort of screen on phone, but could be embedded.
Okay.
And then I would not call that a feature myself, because a feature could be many things. Like a feature could be, for example, onboarding, which is multiple screens, generally speaking. Like you have accept your photo permissions and accept your
Yes.
location permission. So I would say onboarding itself is the features onboarding,
Okay.
which has multiple feature views, and which consists out of components and simpler views like view primitives like labels and stuff. And then when we talk about a feature module,
Mhm.
I would say a feature module is basically that feature, like an onboarding feature, just moved in a module. And also I think a module, it's a very expensive word to just say folder, right? So it
Okay.
lives in a folder. We can make it really complicated with like dependencies and transitive dependencies and packages, but in the simplest form, a module is just a folder. So you put the onboarding stuff in a folder, and now it's a module.
Okay.
So for me, feature and modules are again two unrelated things. You can put a feature in a module, and you can make a feature module. So it's like a module serving a feature.
Okay.
Yeah, I guess that's how I look at it. Of course, this is just my view.
Yes, I agree with you. That's something. It's a philosophic question and a lot
Yeah, I
of
like it.
and maybe we can choose to think about the new application nowadays. It's using a lot the decomposition based on tab bar. I see that I
Hmm.
know that that's a lot of application now. especially from our
Yeah,
side.
since the beginning, I think, of
Since the
mobile
beginning.
almost. Yeah.
But a lot of technical leaders and senior iOS developer, when he tried to decompose their application from monolith code to modular code, he think about
Mm-hmm.
why we try to decompose our application based on tab bar model. Imagine
Mm-hmm.
that we have an e-commerce application that it decomposed from homepage, stores,
Mm-hmm.
checkout, tab bar items, and customer tab bar items. They tried to decompose the application based on the tab bar.
Yeah.
What do you think? It's the best approach to decompose like this, and should each tab bar it's considered like like a model, independent model.
Yeah. Yeah. So, yeah, the best approach I think is not. I can give you one. I just can give you some ideas.
Okay.
Because yeah, every approach and every app is different. But I do think what happens is if you have the tab bar, the most prominent, like the most important features are inside of the tab bar, right? If they're
Okay.
not
Yes.
important, they're hidden away more, right? If they're really important, they're like the first tab, and if they're
Yes.
less important, the second tab, and so on. So yeah, those are the obvious large features. They're probably the largest features in the app, right? Because they are the most important features, or at least the ones that are most important to the app. So those are the ones that are also obvious to switch between, because you can see them right after logging in. You can see the main feature. So that is the default choice to make those into modules. They're the largest feature. They're the most important features. And they're already sort of cut up, because as developers, you already cut them up. You cut up all the stuff into a couple tabs. So yeah,
Yes.
it makes sense to me that you would think of those features as like the primary features to turn into a module. Now, then the question is, why would you want to do this? We can
Yes.
talk about for at length. First of all, you don't have to, right?
Okay.
But I guess organizationally, it can make sense to, if you have a larger app or a larger organization, of course, it may make sense to cut things up into modules and give, for example, teams their own feature modules to maintain. And it creates a lot of benefits, but it also creates some overhead, because now you have to maintain a module and you have to maintain, a package manager and that kind of stuff.
Yes.
Yeah, the big benefit is everybody gets their own little island, like a little package of feature module to maintain. And that's the sort of the ideal way. Everybody gets their own little piece of code and then puts that in the application on the tab bar, and these tabs are not talking to each other. So let's say you have 4 tabs, you have 4 teams and 4 features. Yeah, that's
Yes.
sort of like an easy translation. I think that's like, what's the Conway's law, where the organization turns into the code, or the other way around. The code base turns into the organization. So yeah, so if you have like you have to come up maybe with an app soon, but if you have like a feature in the first tab, and then the second team does maintains the feature in the other tab, well, they don't have to talk very much, right? And they don't get
Okay.
in each other's way with merge conflicts, and that makes things nicer. And also mentally, if you're, let's say you're joining the company, you're joining a team which maintains one of those features, well, it fits better in your head to think about only that feature versus sort of merging everything in one location, and now you need to now you're probably touching a lot of other people's code more easily if you don't create that separation between of modules.
Okay. It's great. Let's come to how to handle communication between models. I see a lot of video to speak about modularization. They speak about
Mm-hmm.
shared models and and um, how they choose to, from your side, how do you decide that this model is shared between between other models? How do you handle communication between different model in modular application? What kind of tools that you use to handle this communication between models, and to decide that this model is shared model, especially when we speak about networking, storage,
Mm-hmm.
etc. That something like login sometimes when we try to call the API, we try to send some GWT information, etc. in every call APIs, and people who decide to create models, they think, okay, networking it will be, or API will be a shared model used by the login model, the checkout models, the stores models. I try to make example for people who listen or see
Yeah,
to
yeah.
us to make concrete things. And what do you think about that? API model should be shared models. Storage model should be also shared. What about speaking about use cases? If you are a clean architecture, we have use cases that will be shared. Do you think that domain should be a model also? What do you think about that?
Yeah, so communication between modules, I think, can be done either top down and
Okay.
bottom up. And let me explain. So
Okay.
if we have at the top, we have an application, right? And below that, we have, let's say, feature modules like onboarding or like a payments module, or depending on your app.
Yes.
And then you have shared modules, I would say, like UI components and networking. Those are always the available pretty much. Every
Yes.
module has some sort of, if you have a feature that is UI facing, you have most likely dependency on UI components and stuff. So that is shared. And then the networking, which is code that's also shared. So you can do a top down from the app, sort of a connection. So let me rephrase that. So each feature module would be sort of self-sustained, so it will deliver its own feature and it does not know about other features. But the app, which embeds the features, or even a module above, but that's like another topic. So the app above these features would embed all these features together and can there glue together all these features, right? So if I have like let's say a payment feature, and I don't know, let's come up with the feature. Like maybe like a magazine reader or something.
Stores, something like that.
Yeah,
Yes.
like well, let's say you can like a store to buy magazines and read them on the app,
Yes.
for example.
Yes.
So you have like a store module and you may have like a payments module, and these modules don't know about each other, let's say, but the app embeds them, and the app knows about those two modules. So the app will trigger respond to triggers from the store. Like the store may be like purchase, and that will send a signal to the app in whatever form you want. The notification, closure, delegate, I don't know, interfaces, whatever. To me, it doesn't matter.
Yes.
And then it would trigger methods on the payments module, maybe present a payments flow. And once the payments flow is done, the app tells the store, okay, it's done. You can now download this magazine you want to read, that you just purchased. But that's kind of like the top-down version where the app glues together modules. But then you also have the shared modules at the bottom. So all these feature modules have UI, right? If they're UI facing. So they would all depend on the same UI components library, which I think is a good choice, because otherwise every feature module has UI in their own module, which means you get like a repeat, a lot of a duplication, a lot of components where one has accessibility figured out and the other one does not have the accessibility inside.
Yes.
So that makes a lot of sense to me to have those shared sort of foundational components, and I see it similar to the foundation in UI kit or Swift UI dependencies, right? Like you build your features, you depend on a shared Swift UI module.
Yes. Yes.
And the same for networking. Like for me, it doesn't make sense to have each feature module figure out their own networking every time. Like why? So make one networking module, and it has to be configured so the app can send maybe some necessary information to the networking module to maybe set it up, like an environment, like which server it's connecting to. But the networking module can then take over the rest. And these feature modules can depend on the networking module just as they can depend on the UI module.
Okay.
Yeah.
Okay.
So I see it that way, at least. Like, share it that way.
Okay. At this moment, it's your philosophy to dispatch or to manage the modularization based on shared modularization. It's the same that we use now at in our job. We have networking shared, analytic shared models, others,
Yeah.
and based we try to dispatch our models now based on tab bar modularization and also
Yeah.
some details inside each tab bar information like payments, etc. And I read last month some new architecture based to modularization, which based they speak about central layer, abstraction layer, that
Yeah.
it's a center of our model. It's a center model,
Yeah.
which I sent you the article in Medium.
Yeah, I saw the
But
article.
yes, so the article they speak about spaghetti modularization because in
Mhm.
each we have models that import 3, 4, 5 models, and
Mhm.
they create a lot of dependency between models. For that,
Mhm.
he
Mhm.
proposed single layers, single model in the center, like if you say composition root pattern, if you if you uh, if you want, and in this abstraction,
CRP.
yes,
It's a new abbreviation, otherwise it
yeah,
doesn't get trendy, of course.
yeah, yes. Okay, composition, but it's not the pattern of composition root. It's a
Yeah.
central abstraction layer that in the side we expose um, every we expose using protocols the different function that the other models offers. And when imagine that we have analytics model that we import in the login model, we don't need to have that. We have we try to expose we try to expose the all the function of our analytic models in the abstraction layer, and we try no need we need to import our abstraction layer in our models. That's why we are central abstraction layer, and it will be from our side in at Sephora. We use this architecture,
Yeah.
and we have a lot of gain of time. We have when we try to compile our models, because we are dependent of abstraction, not of the real models, and we
Yeah.
find that in our models it take a little of 2 seconds, 2 seconds or less to compile. Imagine the order history models in our application, which is a great model in our application. What do you think about that? Have a central abstraction layer in the center of our application,
Yeah.
and try to use this architecture. What do you think, Ted?
Uh, so I
Yes.
think one telling sign is it took a lot of time to explain it, which tells me it's already quite complicated.
Yes, I
No,
know.
not to
I know.
be.
Yes.
No, it's a bit like snarky. But what I mean is, um, so here's the thing: you have complexity in an architecture at one point, right? You have your application, your feature modules, and then shared modules with more modules, or maybe you have like 20 modules at one point or whatever.
Yes.
Um, and then the question is, well, what problem do I have? And what I hear you say is, well, these feature modules, they depend on 5 other things.
Yes.
That's one problem. The other one is compilation, which we can talk about in a sec. But let's
Okay.
focus on the fact that modules depend on other modules. So why? The question for you: why is that a bad thing?
Because when we try to compile our model, we should compile the other models, which
Mm-hmm.
take a time to compile the other models. And
Yeah.
when you compile one models, which is the abstraction
Yeah.
models,
Yeah.
which give us only protocols. There is no
Yeah.
implementation. we have a lot. We can we have when we compile, as you know, protocols, it takes a lot of time, and we have only to compare the abstraction layer. I know that it will be a great, huge abstraction layer at the end, but we can make extension. We can make a lot of submodels in our abstraction layers to
Yeah, yeah,
to minimize the time of compilation of our abstraction layer. At this
yeah,
moment, when we compare the time of compilation, we find that
yeah,
okay, before we take 5-7 seconds to compile our models. Now, when you're using the abstraction layer, we take 1 second, maybe less of 1 seconds, because we compile the abstraction layers and our models. That's why we we have to choose
yeah.
this. Yes,
So it's about time saving.
time saving. Yes.
So I would say that's not the only metric, because you
Okay.
also are losing time by making things more complicated.
Yes.
So someone joins your team, you now have to explain a lot more. You have to, maintain the interface module, which has interfaces to keep it in sync with all the other modules. Everything is more complicated, I think.
Yes.
So that's really hard to measure, right? So if if you have to do all the lot more work, more overhead, then maybe the compilation is like, oh yeah, I press Command B and it's like from 7 to 0 seconds. That is now solved, or less 7 to 1 second. But you still have sort of all these hidden costs.
Mm,
That's how I look at it. I think, from my perspective, I think it's over engineering, but doesn't
okay.
mean that's the one way. I only am one person with one opinion.
Okay.
So here's the thing. In my experience, feature modules and other modules, they compile really fast. And I've worked in many types of modules, many types of multiple apps, large, giant apps. Feature modules actually compile really quickly, in my experience. And they depend on, again, the shared, analytics, UI, networking. Yes, it doesn't doesn't go from 7 to 1 second, sure. But
Okay.
for me, if I have a module that compiles in 7 seconds, I'm super happy. Like, that is
Okay.
great,
Okay.
right?
Okay.
Because I'm used to apps that compile on like 20 minutes, 30 minutes first run. That's like insane. So then you have like this module that compiles in like 50 seconds, even, or 30 or 20 or 7. I think that is already great. You can optimize more, but I would already be really happy with that, to be honest. Um, but the problem I have with sort of the interface modules is a couple of things. If you depend on, let's make it more concrete, more easy to explain. Let's say I have like a payments module, right?
Okay.
And it depends on networking and UI.
Okay.
Okay, so UI module and a networking module. Let's say I don't want these dependencies. Okay, so now we're going to introduce another module, right, with the interface that is sort of like this God interface module.
Yes.
So now you make that. So we now have that dependency, which now have to, this interface, the interfaces inside this interface module needs to now be kept in sync with all its child modules, right?
Okay.
So if the child module changes, you now have to update the other one. So like, oh, I'm going to change the thing, compile, compiler error, go back to the module, change, add the line, okay, back. I think that costs more than 7 seconds. So already the
Okay.
point is kind of, you lost it already, I think.
Okay.
But now it's also more complicated. Because let's say you don't want to depend on the UI modules, a lot of assets, and you want to, there's a lot of compile time. I've seen teams that did this. They completely stopped out with interfaces their UI dependency, which I think was a major mistake, because UI components, well, let's rephrase, like the UI module has a lot of public accessible elements. So like the public API of a UI module tends to be
Yes.
larger than a feature payments module that just has make payment and done, right?
Yes.
So UI, sort of like a lower level module, has more components that are publicly accessible.
Okay.
So that means that if you are going to now mock this out, like stop this out with interfaces, I mean, now you have a giant interface library in that module. So every little thing now has to be cloned as an interface in this other module, which is a lot of overhead and more than 7 seconds.
Okay.
So and the module you're using does not use this dependency right away. So when you run it on its own, so let's say you have a feature module and you want to run it with the proper styling, well, you now have to do something else again to now see it with the styling. So you still are going to compile with the real styling at one point, because it doesn't make sense to, for me at least, to make a feature without having the UI. Like everything would just look default. So, and you don't have all the components. You have all these interfaces. So now let's say you have a custom bottom sheet, right?
Okay.
I make a custom bottom sheet in my UI shared library. Now my feature module, I have this interface, custom bottom sheet interface. I have no implementation. So now, because it's an interface, right? And I want to run my module without all these dependencies. That's the idea, right? So now I'm going to make a fake implementation of this bottom sheet. That is now I have another thing. Now I have like a fake bottom sheet, mock bottom sheet to compile faster. So now I'm maintaining an extra thing plus the interface, and it's more complicated. So I think this goes on a path where you just add a lot more overhead, and yeah, I don't know. I've never seen it really work well. And another thing I don't like about interfaces to hide all the dependencies is the dependencies are kind of moved up towards the app. So let's say the bottom layer, you have the feature module and then the app at the top.
Yes.
Let's say the feature module doesn't have any dependencies, it's all interface. Now the app will contain everything and will order some module above maybe. So now they will then have to inject everything and like be aware of everything.
Yes.
Whereas before, like if I have a feature module, it depends on UI, it makes use of UI. Why hide that fact? Like there is a complexity, right? There's like networking, UI, and all that stuff. And we're just moving the complexity around. We're not hiding. We're trying to hide the complexity, but it's still there.
Okay.
So you just I think yes, it makes it sound really good on paper. Like yeah, the compile time goes down. That is true, but
Yes.
I think the time you're saved is not. I don't know. I think you're gonna spend it in other ways. So and now it's more complicated.
Yes.
So I don't know. I'm not really in favor of it, but please don't follow my advice if you don't agree. That's fine.
No, we have made last week a lot of discussion about that with our teams, etc. There is a lot of disagreement about. It's a good way to go further with this good layer abstraction, and we lot of discussion about that. People are not have the same point of view that we complicated things. No problem to import the other modules, etc. Okay, we have time of we have less time in compilation, etc. But people who will come in the project maybe have problem to understand this good abstraction layer and how to decompose based on this good abstraction layer in the center. It will be not very easy to present this, and we are in technical discussion about that, and it's not our final decision to opt to.
It's okay, whatever. It's your own choice, of course. I do think the compilation time issues are, from my experience, not in the feature modules. They're always in the app in themselves. And there are some things you can do there, maybe, and then maybe have some interfaces there. I don't know yet, but the feature modules themselves, they're usually quite lean. Like they're like 7 screens, 20 screens. Okay, like compiles in 1 minute, maybe. Okay, pretty fast.
Yes, I understand. Okay,
keep it simple.
Yeah, keep simple.
Yeah, your feature module depends on networking, analytics, and UI components. 3 imports. Keep it simple.
Yes,
that's how I look at it.
Okay, great. We have a lot to speak about abstraction layers, about communication between modules, etc. How you define modules, and I know that we make modularization based on our legacy code. It's a lot of challenges when to balancing legacy and new features based
Mm-hmm.
on modularization. How
Mm-hmm.
we can progress with modularization while still delivering new features on the top of the legacy
Yeah.
system? I
Yeah.
think that you have a
That's a
lot
good
of
question.
strategy. Can we use
Yeah.
to manage
Well, I've
this?
done it a whole
Yes.
bunch of times in the past.
Yes.
Yeah.
Yes.
So a whole bunch of things I learned. So first of all, if you want to go from a legacy, like a current sort of monolithic
Monolith.
app to
Yes.
like a modular setup,
Yes.
you again have you have let's do the 3 layers, right? Shared modules like core modules, feature modules, and an app. You have to
Okay.
start with the bottom layer,
Okay.
and the reason is everything else depends on that, right? So let's say you have like a networking layer, right?
Okay.
Let's say it's all spread out in your app, all networking magic you're doing. You have to find a way to extract that first, like at the bottom layer, because everything else afterwards will depend on it. Because if you start with the top layer, like a feature module, well, it needs to depend on networking. How is it going to depend on networking? It's going to depend on the app again. So now if the app depend on the feature module, and the feature module depend on the app. So you have to work from the bottom and go up. One problem I see when extracting features to the modules or code to the modules is how a feature is sort of smeared out. So let's take a feature. They may have UI components in the UI folder, and then the networking in another folder, and then that is sort of okay. But then the feature itself has like multiple files, and they're sort of smeared out across, like let's say a model folder. So like the feature has models, and that puts it in a shared model folder, not module, sorry, model
Okay.
folder.
Yes.
And then maybe there's like I don't know, some sort of logic, but business logic. So there's also moved to a folder. So the feature, if you look at the folders in the physical folders on the drive, it's sort of smeared out,
Okay.
and that makes it hard to extract to a feature. Because if you have a feature module, that is a package, right? It's nicer to have it all already pre-packaged up. You can just like cut and paste and put it in the feature module. So if
Okay.
everything is smeared out and sort of depending on everything, so that's where you got to start. You got to find a way to take the feature, maybe not necessarily the networking, which is its own module, and the UI, which will be its own module. But if
Okay.
you well, in fact, you will first extract the bottom layer, UI and networking. So you have the feature left in the app afterwards. You have to find a way to package that all together. So change your folders so it's more like feature folders, not so much like model folder with models, all the features together, and then business logic folders with all the features together. You have to separate it, create like walls, like folders, and then you can cut and paste the feature into a module. I think that already really helps. When extracting, you really got to think about what is depending on what. So what you can do is, if you have made these folders, you can extract them. You can see already when you compile what's going wrong, like it depends on this it depends on that. So you got to find all the connections, really like make a list of them, figure out if you need more modules, what are the dependencies, can you rethink dependencies, do you really need this dependency, and so on. There was something else I wanted to say. Oh, maybe it comes back. Oh yeah, the public interface.
Okay.
It's good to evaluate the public interface of a module and try to shrink it. Like a small public interface is really, really good to have, because
Okay.
if you have, especially when you extract something, everything is connected to everything. Everything is sort of accessible right inside an application. But when you extract, you don't want everything exposed as public types.
Okay.
That is maybe the first step to make it compile. But you got to reimagine, like, what is this public interface? If I have like a payments feature, originally the app may use like the payments model and the payment screen and the payments confirmation screen and the payments something went wrong screen and the payments navigation, blah blah blah, tons of types.
Okay.
But when it payments feature is in a module, then you may just want to have start payment to start the flow. That's it,
That's
right?
it.
Very
Yes.
simple. And this
Exactly.
is really important, because if you evaluate the public interface and shrink it and have a small public interface, it makes it easier to move a module around. Like physically in the folders to open source to internal repo even,
Okay.
but also makes it easier to use the module. Because let's say I have like a payment flow with start payment, but all I have to do is start payment. So I can use it in multiple places in the app. Whereas before, if the app sort of is aware of all the screens and using all the screens, then yeah, that's get kind of sort of this entanglement and makes it hard to like untangle it
Very
and
coupled.
use it somewhere
Yes.
else. It's very coupled.
Yes.
So to summarize, start with the bottom layer, like networking, UI, extract those. Feature modules, make sure they're packaged. Don't smear them out in your application as files. Put the files together and then extract those. Evaluate the public API. Shared modules will have a large public API. That's expected because it offers a lot of types to offer a lot of stuff. But the feature modules, try to keep them smaller. Yeah, I think that's already a good starting point.
Okay.
And then we can, if you want, we can talk about qualities of modules. I don't know, I'm gonna keep
Okay.
going. I can talk
Yes.
forever now if you let
No, no,
me.
yes. But my it's great. But my next question it's related. It's the risk because generally when we manage, we have
Yeah,
we go to modularization. We have two or three people's developers that work on modularization, and the rest of the teams, etc., work on business demand, etc.,
yeah,
the new features, etc.
yeah,
It's a lot of problems when and the risk because the business in especially in most companies didn't didn't understand why we try to have modularization, and for him
yeah,
there is some the important thing is how to increase our features, how to deliver to our customers, the and the same time you technical leaders, lead developers, we try to make things based on modularization, and we
yeah,
have two teams. The first teams work on modularization, the second teams work on the features, the new features, and the in the end of your sprint we come to deliver the new features based on the legacy code. And the other side, you have the new architectures based on modularization, etc. First
yeah,
things that come to life, the new models, and you try to
yeah.
make rebasing, etc. Handle conflicts and a lot of problem, a lot of risk. Uh, how you? I think that you have you had this issues in your experience how to deal to manage the risk associated with transitioning to modular architecture, especially
Yeah.
when you have this kind of company, etc.
So first of all, the goal of modularization. Yeah, first of all, you don't have to modularize. That is correct. Like,
Okay.
this is just like a choice you want to make, but you don't have to have modules to ship an app. So
Okay.
then why do we want modules? Like, it's very simple thing to say, I know. But like,
Okay.
why do we then want modules, right? Like, what problem are we really solving? And one of the problems is sort of the isolation between features and a more team-based structure. So basically, it's your organization,
Okay.
right? If everybody worked together in complete harmony and we didn't touch each other's code too much and everything would compile just great. But because we're all working together in the same code base, we're like, okay, conflicts, we merge conflicts, and hopefully not real conflicts, but those are inevitable sometimes.
Okay.
Uh, um, so yeah, the goal is that we can create more, like a faster way to ship features, right? That is
Okay.
the ultimate goal, right? We want to work faster and have less problems, right? That is actually the goal. And
Yes.
one of the solutions is modules, so that if you have your own feature, other people don't touch your feature. You can just not merge conflicts in your feature when people are touching other things. So what I would recommend, if you want a modular setup, is to at least consider um, extracting the low-level modules, because you need those if you ever want modules, right? Those are the first ones. And
Yes.
then there is a big difference between building a new feature as a module and turning an older feature into a module.
Yes.
And if you have the shared modules like a UI components and a networking module, you can build a new feature in a modular way.
Okay.
And that could be very interesting already. That doesn't mean you have to go back and refactor old features. It just means you have to extract the base modules, which is sort of painful but still doable. And the new feature module will then be completely new. And then once an older feature is removed, you can delete it in the app. And then in the new feature, you build a new feature module. So you can sort of gradually move to new feature modules, if that is the end goal. To if you really want to extract current features, it's refactoring. It's a lot of time. And again, what I would recommend is packaging them up. Not even make them modules, but like I said, like find your features, try to make sure they're not smeared across the app, which they usually are, because they are just sort of smeared out with the models and everything. Try to make them full. Just make a folder, right? Let's say you have a
Yes.
payments feature. That's
Yes.
a legacy feature in your app. Folder, payments, put everything payments related in there. Like find it in your tree, your drive, and make that group. Then a few weeks later, you evaluate the public API. You just try, or you can just extract it into a module and see what happens if you compile. You learn how much work you have left. You can make a decision. You can say, well, this feature is really tough to extract. And sometimes you may learn like, oh, it's actually 3 places we need it. So that's easy. I just make a new interface or a new public API. That's what I mean. And then you can extract it. So yeah, I would focus on new features, make them as how you want them.
Okay.
And you can only do this with shared lower level modules. And then decide if it's worth it to extract existing features.
Okay. Let's come to specific about reviews process when we are in this kind of modularization architecture. What code review process do you recommend when working on with modularization application? Because generally we have a lot of features teams, different teams composed of, imagine that we have the payment modules with 2 developers, we have the stores modules with 3 developers, we have the home the modules with 2 developers, and this all the developers work on different modules. How kind of review process, and you are the technical leaders, you are the team
Mm-hmm.
leaders, you are, how
Mm-hmm.
kind of code review process do you recommend when working with this kind of modularized application?
Yeah, maybe a bit naive. To me, it's not really that different from other review processes. But what I do recommend is that, regardless if you use a module or not, is to have teams outside of your feature review as well, not just your coworker that sits next to you, because you create this sort of bubble where you and coworkers start approving each other's merge requests or feature pull requests, and then people on momentum, which of course is nice as a developer. But
Yes.
I do recommend always get like an outsider, like someone else from a different team, to also approve your pull
Okay.
requests or merge requests sometimes to get a little bit more expected, minimum checks. What I also recommend is to really safeguard the APIs. Again, keep the APIs small. Make sure that
Okay.
you check on this. What I also recommend is, well, let's see. So if your modules are in the same workspace,
Yes.
everything will compile together. It's still, you can still treat it as one project. But let's say you have a module in a different repo. For maybe it's a shared module for multiple applications, right? Like a foundational. Then things change quite a lot, because now you have to make sure you don't break the public API of a module. So, for example, what I proposed a long while ago, my work was, which was quite useful, was to run before you make a new release of a module, which the whole versioning approach is a bit more formal.
Yes.
You would run it against the application to make sure it still compiles. Otherwise, you may accidentally break something. So just doing that really helped by doing some checks. So that makes a big difference in how you treat a module versus an application. What I also would do, not just code review related, but if you extract a module, you
Yes.
can create a really nice sample app to run the feature inside. And in this sample app, you can run UI tests. So you
Okay.
can make a simple list view, or like a table view, and each row is just a scenario or like a payment. Let's say you have a payment flow. You can have like, let's say 3 various flows. You can run them as a sample app inside your module. So your module has their own little sample app, which is really nice to go into a module and see how even it works. Let's say someone joins your team and just wants to see which flows does it offer. But also it allows you to run UI tests, and you can run these periodically for that module alone. And they run quite quickly because they're very few tests, right? They're not like a giant app that has to build and before you can test your flow. It's like a small app. Um, and because the point of reviews is quality checks.
Yes.
But the point is reviewing is not to keep each other busy. It's to make sure we have no bugs and make sure the quality is still there. So having a little app with each module is a big win. You can run unit tests just inside the module. You can run UI tests just for the module. And the app does, if the app integrates, again, this payment flow, it doesn't need to test every screen. It just needs to know if it starts and if it finishes, because it's the integration, because the module itself already tests the screens.
Okay.
So you can run UI tests faster in that sense. But if it comes down to just code reviews, yeah, for me, it's not that different than other code reviews. I think it's good to have sort of a cross-pollination between developers there in the code to just see other people's code. I think
Yes.
that's maybe better than to, I guess that's the pitfall. You have a module, 2 developers, and they just started proving each other's
Yes.
pull requests all
Yes.
the time. I would avoid that.
Yes, you advise to have this communication between team features that not the developer that works in the same. Imagine that you have the payment team features, not the other developer that verify or make the review, but
Yeah,
another developer, another team. Imagine the stores team, the customers team that validate
yeah,
the pull request. And what about this shared models? Imagine that we have
yeah,
changes in the shared models that
yeah,
it's used by every teams.
yeah.
What kind of reviews? It's all the teams that should reviews, or only the technical leaders, the iOS. Uh,
So
mm,
So my experience, the more senior developers tend to deal with the shared
okay.
modules because they are more critical.
Yes.
Because if you have introduce a bug in your feature module, your feature breaks. If you
Yes.
introduce a bug in your networking module, all the features break.
Yes.
So you gotta. I'm not saying you should not hire junior developers. I say add those to the team as well. You want those
Yes.
too, because they have different view on things. But the public API for module is holy. That is what you must test thoroughly. So, and this is why a small public API, if possible, is even better because
Yes.
you can you have to deal with less issues. For example, if I have a class and you can subclass it, well, it's really hard to test against how people are subclassing your class. So,
Yes.
my experience, I rather avoid subclassing and make it final, so you can subclass because you have a more controlled environment. Because you can still solve a lot of programming problems without subclassing.
Yes.
Not everything, but well, maybe. But my point is, you want to have a good definition of the public API of these shared modules. With networking, for example, you want to everything thoroughly tested. Like it just can't break. That's what you want to go for. It's not fully preventable, but like get it done really well. For the UI based modules, well, it's going to be UI tests. I know developers are very allergic to UI tests, but you got to do something.
Yes.
And again, I think a sample app, especially for the UI components shared module, is critical because what happens is if you join a company or a team or whatever, you're going to go into a sample app if it's there for this UI components library. Check out all the colors, check out all the
Yes.
components. It's great to see a visual representation what is out there versus reading, custom control. What is this custom control versus just seeing it?
Yes.
And on top of that, you want a lot of tests. Like you could do like snapshot tests or UI tests. Snapshot test is another whole thing because you have to maintain screenshots.
Yes.
But definitely get those thoroughly tested. And it's worse let's put it this way. It's more important to test the shared modules than the feature modules, in my opinion. Because shared modules, once you break networking, the whole app breaks, right? Versus
great.
a screen.
That's a good good explanation of especially how to review shared modules. What about if this shared modules it's used in different projects? We can speak about version control of the module. And I know that you have a lot to speak about that, especially in SPM, semantic versioning, etc. For people that, what are the best practice for versioning when dealing with modules, especially for shared modules, like
You know,
utility.
the hour.
I know.
I shared the talk I did. It was like literally an hour about this
Yes,
topic.
yes.
So I can do it now in 10 minutes, but to make it simple.
Yes.
The public API is holy, absolutely safeguarded with your life. That make sure that the public API does not break. Make sure you have a lot of tests and a lot of checks. Like I said, run it against an app to make sure that before you make a new release, so to ensure that you didn't break versus just releasing. What I also see a lot of developers do, they're like, I made some changes, and then they gonna go to the app, so they check and they see like, oh, I broke something, so now they're gonna make it a major. They're like, oh, it's a major because I broke the public API, right? And that is a big mistake if you think about it that way, because you're gonna have majors all the time. And the problem with a major release is that it impacts the entire modular setup you have. So you can get, for example, the dependency hell problem, where if you have a breaking change, then another module cannot resolve. Sorry, the dependencies cannot resolve, because one module is let's say I have a dependency on version 4 of a feature module, dependency feature 4 of the networking module, and another feature module has a dependency on feature 5 on the networking module. It's not going to resolve, so you can't move forward. So this halts the entire release and the organization. So you got to avoid major releases as much as you can, or if you have a major release, really make it a deliberate choice, and then you plan it in, and then you make sure everybody updates to the latest version. So there has to be a plan. So what I see developers do often, they're like, like I said, like, oh, I broke something, so it's a major, and now they don't realize, like, you just made people miss their own release because other teams migrated to this new one, your team did not, and now the feature modules that cannot resolve this shared modules, so now it's a big problem. So then people start like panicking, like, oh, we're gonna miss the release because the dependencies are wrong. So safeguard the public API with your life, and then try to avoid the major releases. And if you make a major release, plan them in. And also, if you have a kind of complicated tree, there's a whole way to release a whole order to them. So first you update the lowest level, then the next level, and then the next level, and so on. So everything is updated. So make sure you have a plan for release management. So that means you have someone that is outside of their little scope of a module that oversees the entire thing, like a team lead or something, or a platform team that oversees the whole release process. That is important, because if you have like your own team and they're like, oh, I just look at my own feature and it's just a major. Here you go, everybody. Here's my major version. Now the entire department, the mobile department, suffers. So you need someone that sort of oversees this.
We have
a short answer.
Yes, I know that's. But you have a great talk in GoTo in I think 2019. We speak a lot about scalability of the US application. You speak about semantic versioning, etc., and sharing modules. We will share this in the description of our podcast for people who listen or watch the episode. I think that we have for this episode, we have a lot of things that we discussed about modularization. There is other things, that, especially about dependency injection in modularization, but it takes a lot. Let's talk, I think, and also the deep links. the dip links because it's great, important things. How
Mm-hmm.
to handle
Yeah.
dip links. But maybe we have another talks about that.
Sure.
I think it's better to speak about dependency injection, how to
Mm-hmm.
handle deep links and other things
Mm-hmm.
in the next talk about that.
Mm-hmm.
Can you? I let you to finish this podcast about your advices. What do you think about modularization and your experience? And what do you think?
Yeah, I'm quite in favor of modularization, especially if you're going to make new features. You don't have to start with the module, but you can because it saves you some time. If you know, here's the thing: for some modules, it's really clear. People say like, if you make something new, start with the module, which is kind of those like the things that fits in a tweet or post, and then it's like nice advice, which makes sense for a feature module. But I think the view challenges are shared modules. You can't just say start the new module and then the shared stuff will automatically be fine. It's a lot of hard work. I think modules make a lot of sense. I think it fits an organization well if you have teams that have their own module. But you got to think about how the modules go back inside the app. And that's where, again, the merge conflicts come in, because then you have multiple people, again, sharing the same code again. So that's where the tab bar is maybe nice, where you can still sort of keep that separation. That's one example. But I think the shared merges are the real challenge here.
Yes.
Uh, and I think you got to really have some good people on those modules to really make sure they don't break anything. If you make an update, you don't break a feature that you're not aware of. Make sure you test properly, all that stuff. But then it becomes a superpower. So I know people are allergic to dependencies. They're like you said, it needs to be by the interface. But I feel the opposite. I feel like if I get some good components, I'm really fast. Like if I have like a feature and all the components are already pre-made for me, I can just grab them and drag them in my screen. It works great. That is like a superpower. That is where the speed lies. So I would say embrace the dependencies and use
Yes.
them, and don't be afraid of them. Be like, go away from me. Let's introduce more interfaces. I would avoid that mindset, and I see that mindset quite often, but I'm really not agreeing with that.
Yes, yes. This is a
So
challenge. We try to embrace this modularity and
yeah. Well, yeah,
it's a,
maybe you have really good insights and could help with the with the compilation time, which is
yes.
different per app.
From our side at Sephora, we begin this to try to decompose everything
Mm-hmm.
in different. We have until now 10 modules based on top down modules, especially for analytics,
Yeah,
networking, etc.,
yeah,
based on clean architecture. But now we working to have this features, little features modules to because we are now we try to have a lot of developers, many features teams, etc. At this moment, we thought about modularization for features modules because we
yeah,
before we didn't have
yeah,
this need because
yeah,
usually when you have a lot of developers, we try to think about modularization.
yeah. And also one thing I like to do is think about your module as if you're gonna open source it. You don't have
Yes,
to, but pretend you are UI library module maintainer. Pretend you're gonna open source it. Like, what would that look like? It would have good documentation. It would have a sample app. It would have examples. It would have example code. It would have use
okay,
cases. It would have proper testing. Like,
yes,
pretend your organization is sort of an open source style organization. Uh, that is, I think, a good mindset, because that clears something up. Because when you think about it that way, you're not going to make a lot of abstraction interface modules. You're just going to make sure you have a good feature module and a good UI components module, and they're really well tested. And they may have a dependency, but you prefer to maybe keep them in check. Yes, third-party dependency is another topic which we didn't cover, which I would say, those you maybe should hide behind interfaces, because they are other people's code breaking your code if you're not careful.
yes,
But your own code, don't be afraid to depend on them, and then treat your feature module or your networking module as if you're gonna open source it. So like, what would that look like if you put it in a repo? Like, would it have documentation and all that stuff I just mentioned, right?
Okay,
Yeah.
great.
So
It was a great episode for me with you to speak
uh,
about modularization.
yeah, it
We
was
respect
fun.
the hour. We have 1 hour.
Yeah,
We are great. I'm sure that we have next talk about other aspects, especially when you speak about dependency injection, how to deal with deep links
yeah,
and other things. You promise that you will be in Swift Academy podcast in few months.
yeah. That sounds good.
Thank you. Thank you.
Okay.
Have a nice day and thank
Have
you,
a nice
Tjeerd.
day.
Thank
Okay.
you.
Bye.
Bye.